The Big Bang is a concept that has shaped our understanding of the universe, forming the foundation of modern cosmology. According to Einstein's theory and what is known as textbook cosmology, the Big Bang was the moment the universe began its expansion, marking the creation of all matter, energy, space, and time. This event occurred approximately 13.8 billion years ago and gave rise to the vast universe we observe today. However, recent developments in cosmology suggest that the Big Bang might not be the absolute beginning. Instead, there could have been a phase before the Big Bang that was equally important in shaping the universe as we know it. This earlier period is known as cosmic inflation. Inflation is one of the most intriguing aspects of modern cosmology. It proposes that before the hot, dense phase of the Big Bang, the universe underwent an incredibly rapid, exponential expansion. During this period, the universe was doubling in size at a mind-boggling rate. To illustrate just how extreme this expansion was, if the universe began smaller than an atom, it would have grown to be significantly larger than the entire observable universe within a tiny fraction of a second, about a millionths of a second. This expansion phase did not last long, but it played a crucial role in shaping the cosmos. When the inflationary phase ended, the energy driving this expansion was dumped into space, heating it up and creating the particles of matter that make up everything we see in the universe. In many ways, inflation is the precursor to what we now think of as the Big Bang. While the theory of inflation is widely accepted in cosmology today, many unanswered questions remain. For instance, we do not yet know what started inflation in the first place. What caused it to stop? How long did it last? These are open questions in cosmology, and answering them is crucial for a deeper understanding of the origins of the universe. Before inflation, the universe was an incredibly dense, tiny point of matter, often referred to as a singularity. From this singularity, the expansion began and eventually led to the formation of atoms, molecules, stars, and galaxies. The idea of the Big Bang as the beginning of everything is appealing, but modern cosmology suggests a more complex picture. Some theories propose that the universe underwent a phase before the Big Bang. During this phase, inflation caused the universe to expand at an exponential rate, doubling in size at least 80 times in a fraction of a second. This rapid expansion was fueled by a mysterious form of energy that permeated empty space. When inflation ended, the energy that had powered this expansion was converted into particles, heating the universe and leading to the hot, dense state we call the Big Bang. This inflationary phase was cold and empty, but it set the stage for the creation of matter and the universe we observe today. Eternal inflation and the multiverse. One of the more speculative ideas in modern cosmology is the concept of eternal inflation. This theory proposes that inflation did not stop everywhere at once. Instead, it stopped in patches, creating many different regions or bubbles, each of which could be a universe in its own right. Our universe would be just one of these patches. According to eternal inflation, there could be an infinite number of these universes, each with its own set of physical laws and constants. This is where the idea of the multiverse comes into play, the notion that our universe might be one of many, or even an infinite number of universes. If this idea holds true, it might explain why our universe is so finely tuned for life. In this multiverse scenario, every possible combination of physical laws could exist in different universes. We happen to live in one where the conditions are just right for stars to form and for carbon, oxygen, and other elements necessary for life to exist. While theories like eternal inflation and the multiverse remain speculative, the concept of inflation itself is grounded in experimental evidence. The strongest support for inflation comes from the cosmic microwave background radiation, CMB, the oldest light in the universe. The CMB was released about 380,000 years after the Big Bang, when the universe cooled enough for atoms to form. At that point, the universe became transparent, and this light has been traveling through space ever since. By studying the CMB, cosmologists can essentially take a baby picture of the universe. The light provides clues about the universe's earliest days, helping researchers understand what happened right after the Big Bang and offering support for the inflationary model. The fate of the universe. Just as the beginning of the universe is a subject of intense study, so too is its eventual end. The best current estimate is that the universe will continue expanding forever. This is due to a mysterious phenomenon known as dark energy, which is causing the expansion of the universe to accelerate. Before the discovery of dark energy, Scientists believed that the expansion of the universe would eventually slow down due to the gravitational pull of matter. There was even a possibility that the universe could stop expanding and begin to collapse, leading to a big crunch. However, dark energy seems to be pushing the universe apart faster and faster. If this acceleration continues, the universe will keep expanding indefinitely, eventually reaching a state where galaxies drift so far apart that they become isolated from one another. In this scenario, the universe would become cold, dark, and empty. Stars would burn out, galaxies would drift apart, and all matter would eventually decay. This is sometimes called the Big Freeze or the heat death of the universe.